Let's continue looking at angles in a circle, and we'll look at the cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral with each vertex lying on the circumference of a circle. So remember, the quadrilateral has four sides. Closed is a four-sided closed figure. So let's draw a quadrilateral in this circle. We have this side, we have second side, third side, the fourth side, and we have four angles. So we have this angle, and this angle, and this angle, and this angle. Now, the cyclic quadrilateral. In this, the opposite angles of a cyclic quadrilaterals are supplementary. That means they add up to 180 degrees. Suppose you have angle A, angle B, angle C, angle D. It means that angle A plus angle C is 180 degrees, and angle B plus angle D is 180 degrees. So you have A and C are opposites on opposite sides, opposite angles, of the quadrilateral. This is B and this is D. Opposite angles. That basically means is that if the quadrilateral was like this, right, this angle would be to the left and this right, the opposite. This angle would be to the top and this the bottom. They are opposite, right? Opposite angles. Alright, so they are supplementary, the opposite angles on the quadrilateral, on a cyclic quadrilateral, meaning that it's on a circle, on the circumference of a circle. Let me see if I can move one of these points. I'll move this point up here. And I move this point here. And this one here. Now, if I could adjust them to make the sides all equal, then what would happen? I would have 490 degrees. So that you have 90, 90, 90, 90. And everything would add up to 360 degrees, right? Everything would add to 360. That means up here and down here, opposites would be 90 plus 90, which is 180. This would be 90 plus 90, which is 180, right? Suppose now, let me erase my angles. Suppose I move this point very close to here, and this point very close. What it would mean is that this angle would get very small, going towards 0, right? It would be going down towards 0 as I move closer and closer. This angle would get large. It would lead up towards a straight line, 180, as I move closer and closer. So 0 plus 180 is 180. If I should go close enough, I would have a 90 degree here, and a 90 degree, they're getting closer and closer. At the same time, 90 plus 90 is 180. So it's seem to be working. They are indeed supplementary. They will add up to 180 degrees, right? So as I move these points closer and closer, this angle heads towards 0 while this angle heads towards 180, because I'm trying to get a straight line here, and 0 plus 180 is 180. This angle would head towards 90 and this angle would head towards 90, and they are opposite angles. 90 plus 90 is 180. Alright, seems fair enough. So the angles in a cyclic quadrilateral, where those angles are opposite angles, they actually add up to 180. Let me make a little adjustment here. Now, suppose I want to consider the statement that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. What that really means is that if I should extend this line up here, right? If I extend this line here and I find this angle, let me get rid of this point here. Alright, I find that angle, right? And on the opposite side up here, I find this angle. What this statement is saying is that the exterior angle of a cyclic quadrilateral is equal to the interior angle, where this is the exterior angle and this is the interior angle. That they are equal, always equal. Is that really so? Let me see something here. If you continue this angle all the way around, it would be 180 degrees, right? So if you call this angle, alright, if you call this angle X, right, and call this angle Y, X plus Y would give you 180 degrees, right? Now, earlier we looked at the fact that the opposite angles, the angles that are opposite, are equal, and the opposite angles in a cyclic quadrilateral are equal, right? No, I mean not equal, they add up, are supplementary, they add up to 180. So this angle here, let's call it A. Angle A plus angle Y would be 180 because A and Y are opposite. We're just trying to think about that statement, that argument, that the exterior angle X would be equal to the interior angle A. Let's try to figure out what they're saying. We're scrutinizing it to see if it could possibly be true. Or is it false? A plus Y would give you 180. So if you transpose, you get A is equal to 180 minus Y. You see that? Subtract Y from both sides. Let's look at this now. We said that X plus Y here, right? This angle X plus this angle Y would give 180 because all the way around is 180. Now, A plus Y would be 180 because they say that the angles and the opposite angles in a cyclic quadrilateral are supplementary, they add to 180. Let's transpose this for x and see what would happen. X is equal to 180 minus y. Hold on. You notice we say a is equal to 180 minus y and x is equal to 180 minus y. So if that is so, a is equal to this and x is equal to the same thing, then x and a must be the same thing. So let's just get rid of the a and call it x because it's the same, it won't make a difference. Alright, call it x. Let me see now. Let's get rid of these things. This, alright. So it seems reasonable enough. Oh, you see, what happened? This statement is true. It is true. X here, this angle here, and this angle here would be the same, right? The angles would indeed be the same. All right. So that is the case. So that's the case of the cyclic quadrilateral. Cyclic quadrilateral, quadrilateral where the vertices, that's the corners, right? Where the angles meet, are on the circumference of the same circle. Alright, I'll see you in the next video.